Hello and welcome to the second video of this series. The first one should have shown how to set up PXE booting, and this one I'm going to show how to set up a Yocto build system and then subsequently deploy it via PXE. So this isn't just simply how to use Yocto. Please refer to that documentation for that. This is more how to set up Yocto to support PXE booting. And there's a few things within Yocto which already have that functionality, but there's a few tweaks we need to make in order to get the final bits that we need. So to get started, I've created this repository on my GitLab where I have the submodules I need. So I've got BitBake for building. I've got Meta-Intel as my hardware support layer for my actual end machine, which is obviously Intel. I've got this Meta Mate. So the examples I'm going with are going to use Mate 2, which is a real-time application framework, which is configurable and used in Fusion quite a lot, in ITER and Jet and so forth. It was what kind of spun off this project at my organization. And so my layer is called Meta Mate because it brings that application into the image. Then we've got the standard ones, Meta Open Embedded and an Open Embedded Core, and I've kept them all named as their repositories. And I've got some local config files as well. So this should be, if you're familiar with Yocto, this should be fairly recognizable. I do give a mention that, yes, this kernel is set up for real time with a preempt patch, and we're going to set this up for NFS booting. Later, of course, in this series, I'm going to show more and more of automating this process, creating pipelines that can actually build that image, and then pipelines that can then subsequently test that image. And we can trigger that process from other pipelines as well, from other repositories as well. So, for instance, so let's go back to, so I've got this Mate 2 extra components. That's where I build new GAMs, and that's what my users are going to be doing in my project. And when they push, that pipeline is going to trigger a new build of the image. So the image is re-released with the new changes, and subsequently also we test those changes on the image, on hardware in a Docker. So we test it on multiple levels, not just as an isolated application, but the image included. Cool. So to get started, you can clone this and submodularly, recursively pull the submodules. You will also want to create a Yocto folder on the root, because that's where I've set that up, although you could change that in the local conf if you want. But I've set it up so that I can catch my build files. Just speeds things up every time that we go around and build. We'll do that in the runner as well. And then we want to source the environment initialization script and then build our image. But before we get onto that, I'm just going to show some of these files. So the first one is BB layers. That's very easy. It just says what layers we add. We've got Meta-Intel and Meta Mate at the end. Otherwise, we've got very standard ones that we would usually expect. One we might not be familiar with seeing is Meta Init RAMFS. I think also Meta Networking and Meta File Systems are required here. Meta File Systems giving us NFS support, Meta Init RAMFS giving us some of those initialization scripts that we'll need. So let's go to Meta Init RAMFS. I'll just give a quick intro into that and how that works. If this would actually load up. Oh, so it's okay, cool. So if we look at Meta Init RAMFS, it gives us it gives us a debug script. Let's have a look. This is for the images. Okay, this just gives us the basics. Some of the tools needed. Okay, we'll come back to that. That'll be something later in the series anyway, when we actually, it'll probably be around the end of the series, when we set up other types of booting as well. But anyway, so next let's have a look at local.conf. And here is where I tell it that I do want to build an init RAM file system. I want a max size to be 220. However, you can modify this to be whatever size you need. It might say that you exceeded this max size, so you just need to increase that number. I want to have systemd as well. That's kind of essential. I want to have the file system produce an ISO and a tar. I want the init ramfs file system to be ext4 and give me a CPIO GZ, which is what bootloaders typically expect. I want my kernel to be BZ image type. And then I have some things specific to me, so supporting UK keyboards, you might not need this, and minimizing my work files. So I use rm work. If you're, again, familiar with Yocto, you'd know what those kind of do already. I have some variables which I actually use in some of my recipes. I want to make the whole system work faster, so I have these settings as well. I want package management. I really like the package management attributes of Yocto. I want an empty root password as well, and I want to allow empty on my SSH, so I can just straight away SSH into it as soon as it's booted. We'll see that at the end in our example. And then I want my virtual kernel. I want my kernel to be the RT kernel, and I want my machine to also be RT. And cool. And then I catch my build files onto Yocto, and I set my package management system to be IPK files or OPKG. Cool. Not much to add there. So let's move on to having a look at our Marty repository. So in my core, the main thing to mention is, well, I mean, you can have a look at all these recipes afterwards. Main things to mention is that when, like I said with Ubuntu, when it boots up and it's booting up from NFS booting, the IP address needs to stay consistent, and you can't have it switch from one network interface to another. So we set up this wired network file, and we install it into our system configuration directory. So this tells it to, but it's a critical connection, keep it, right? Don't change it even after booting up. So that makes sure that doesn't happen. We also want to add to our init RAM file system. So I want to add the root, the NFS capable recipe. Now that is somewhere. So that was kind of what I was looking for before. So if I go back to here, now we search in here as well. Does seem to be disappearing from us. It might be in this one. Getting there. Cool. So we have NFS root fs. Yeah, that was the file I was alluding to before. So we want to ensure we have this. This basically is just a normal shell script. Well, not normal, but think of it like, it is a shell script, and it looks for certain boot parameters at startup. So if we've defined dev nfs, which we'll have a look at later on, and specifics on like where is that location of that NFS, some boot flags as well, like is it read only, for instance, all of which we'll put into our menu entry when we build up our grub menu. So yeah, we want that on our init ramfs, so it supports those boot parameters. We then want our image RT that will add our packages to that we want installed. Specifically, also I want OpenSSH, and I also add in the file system, but I want tar bz2. That's important. I want ext4, but really it's the tar bz2 that's important to me. On my main image, I also put that as well. So I've got a minimal and my main. And obviously main will have everything that is included in minimal. So all those packages defined here will be in my main. Okay, so the only other things to mention is that on the Linux RT side, I also add the enet.conf, and the enet.conf just adds support on the kernel level for Ethernet. Again, that's important for the bootloading process. Obviously, we need that Ethernet connection with the kernel. Another one finally is SDN. Again, that's specific to that's more specific to Mate 2. Has no repercussions on NFS booting, so we don't really need to care about it. The only final thing to mention is on my conf level, I've defined the machine and the RT machine. So while Meta Intel defines my Intel machine support, I want to define this RT level where I've isolated some CPUs and I've got some boot parameter settings. So the kernel will boot with these parameters. And this is actually from the Mate 2 documentation on how it works. So welcome to, and then deploying. And yeah, that's basically where I got that from. So that's all of our Yocto setup. We're pretty much ready to go. That should describe everything here. If you have any questions, you can always feel free to pop me a message on the YouTube video in comments. And let's get started. So I already have it, obviously, all of this set up on my own machine, and I've actually pre-built this, so it should be fairly quick. So all I really need to do is source my build environment and then actually build my image. And I'll get going now. Starts by a long process of parsing recipes. Again, it's all pre-built, so it should actually be quite happy to just go right ahead. I'm going to pause here because this can take some time, however. Okay, so now it's built. It was a bit troublesome. I had a stale glibc, which can be fixed by just deleting it by doing bitmap c clean and then glibc for that recipe, and then rerunning. And I also ran out of actual disk space, so I mounted a external hard drive I have, and then used that as my Yocto directory, and that's what you see all up here. But now it's built, and I've got the file contents in my, let's just double check, deploy, yep, and then it's in images, and then it's in Intel, and I've got all my contents here. Now, thing to keep in mind, I mentioned this in video 1, was microcode, well, sorry, init ramfs is actually a .cpio.gz file. So we've got that up here available for us. Sometimes it's referred to as microcode. In this case, we're using this one because that's what we built and we know what's in there. We've got our kernel image and we've got our actual rootfs. So we need to transfer all 3 of these files over to my Raspberry Pi. And on my Raspberry Pi, I also want to create a directory to hold my Yocto files. So I'm just going to also change the permissions on, oh, did all of that the wrong way around. tftp, Yocto, do that as sudo. Cool. And now let's sftp. Sorry, my brain needs a bit more coffee, I think. 1, 2, 3. Image, and we'll put that at so we're still sort of acting from my build directory, so that's what. Right, so I'll take a second. Okay, now let's get our init ramfs up. So we've got this very long name of things, and we want to do init rd. I'm just going to call it that. That's it. Maintain some consistency, a bit consistency here with Ubuntu's kind of style of things, and generally most of Linux systems. And then this last one is going to take quite a while because it is the whole shabazz. cool. And then we want to grab all of this. And I'll pause the recording there because, yeah, this will take quite a while. Okay, so now my tar file is actually on my machine. So I'm going to go back to my Yocto, my Raspberry Pi. I'm going to move to my Yocto, and then I'm going to extract my tar file. Okay, cool. Just wants to make sure I get the right tar commands. Okay, so we're going to go tar xf root fs.tar.bz2. Hopefully this works. And then we're going to call it root is our target directory. Okay, now that's the whole root file system, so that's going to take a while, so I'll pause again. Okay, so now that that finally has extracted the whole root, and you can see we have what we'd sort of expect. Also got a home directory with my root, it's got my projects, and then it's got my Mate2 files as well. So I've got this one I've got for my grub menu. I'm not going to bother with a legacy boot menu entry, and should be able to just add it in. So we can see we've got the definition of where the kernel is, where the init RAM FS system is, and then also where the root is. And then of course I've just added on to the end because it's safe. It's pretty advisable to not only put it into the kernel boot parameters in the Yocto, but also in the actual boot parameters setup. And finally, I've got my NFS root, and that's the one thing we haven't actually set up yet. So we should kind of do that. So I'm going to start by actually installing NFS kernel, making sure we have that installed. So sudo apt install y, there we go. Great. And then I want to add into my etc exports, and I'm going to do this manually actually rather than using nano rather than using echo because it's been a bit glitchy in the past. I think it might be some permissions kind of thing. And we're going to share the whole of our tftp folder across the whole of the IP range 192.168.1. These parameters you see afterwards are pretty necessary for the particular setup that we're going with for NFS. So if you're ever doing PXE booting, this would be the parameters you'd want to set up for your NFS sharing. So just do that again with cool. And finally, restart our NFS server. Brilliant. So that should now be set up. So what I'm going to do is I'm going to move over to my laptop, my Intel machine. And I'm booting it up. In the BIOS, it's actually set up for PXE booting, of course. I think it's going to load the grub menu. Of course, you can't see any of this. I'm selecting to run Yocto. I'm getting a blank screen because my Raspberry Pi has been doing a lot of work today, so it's a bit slow. But it will load, and yeah, it's now loading my kernel image. That's loading up. And now that's loading. And update is complete. And I've got root login. It was actually pretty fast, and I'm logged in. So that all worked. So I'm pretty happy with that. And hopefully you are too. And in the next session, what we'll do is we'll automate the build of our Yocto from a runner in GitLab, and then we'll look at deploying it as well. So that next section is, well, we've already set up our repo. So Everything is accessible through my automated Yocto examples. We're building up these as we go. So focus has been today on this nice repository, and this will be probably not what you see exactly, because you'll see the next steps when you actually get to going to these repositories. The next lesson's already been written up. So we'll do a Docker image that can build our GitLab, build out our Yocto image. We'll then run that on a GitLab runner in our pipelines using GitLab YAML to set up our pipeline. We'll have a deploy script as well, which will place the image. Which will basically manually do. Yocto is going to work on this PC, and then manually it's going to do something like this. SFTP it over to my Raspberry Pi. Then we'll be able to load from that image. So great. Look forward to it. See you then.